Good evening all. Today we will see question number 13. Last class we completed up to question number 12. So question number 13 is given that on which of the following interval the given function f of x is strictly decreasing. So f of x is given that x power 100 plus sin x minus 1. So which of these interval the function is decreasing, they are asking, strictly decreasing they are asking. So we have to find first f dash of x. So f dash of x value we will find and keep. F dash of x equal to 100 into x power 99 plus differentiation of sin x equal to cos x. Now what is the first interval given here? First interval is given that 0 to 1. So we know that 0 radian equal to 0 degree, 0 radian equal to 0 degree, 1 radian approximately equal to 57 degree. So our interval is clearly 0 to 57 degree, 0 to 57 degree. So clearly in this x power 99 is greater than 0 for all the value of 0 to 1. So multiplying 100 both sides means 100 into x power 99 is greater than 0. We can keep it as equation number 1 or inequality number 1. Next, the function cos x is positive in the 0 to pi. So we can write that cos x is greater than 0 for all x belongs to the interval, open interval 0 to 57 degree. So this one we can take it as 2. We can add 1 and 2. Adding 1 and 2 implies we can get 100 x power 99 plus cos x, that will be greater than 0. So that is nothing but f dash of x. So f dash of x greater than 0 means clearly we can say f of x is strictly increasing on the interval 0 to 1. Clear? Next question. Next option B. So B subdivision given here pi by 2 to pi. So it is given that pi by 2 to pi. So converting pi by 2 to pi, converting this into radian means pi value equal to substituting 22 by 7. I will get 22 by 14, comma, pi equal to 22 by 7. So it is always positive. So we can clearly write that x power 99 is greater than 0. So multiplying 100 before, 100 into x power 99 will be also greater than 0. Keep it as equation number 1. Clearly we know that cos x is less than 0 in the interval for all x belongs to the open interval pi by 2 to pi, because cos x is negative in the second quadrant. But cos x negative means minimum value of cos x is minus 1. But this value clearly this is greater than cos x. So I can conclude that 100 into x power 99 is greater than cos x. Greater than cos x. So clearly it is greater than cos x means we can write that f dash of x value is clearly greater than 0, because it is a very minimum value, it is very large value. So subtracting means we will get positive values only. So f dash of x greater than 0 means we can clearly say f is increasing or f is strictly increasing. F is strictly increasing function on the domain what is given here, the interval pi by 2 to pi. Next option C. So option C is given that 0 to pi by 2. Option C is 0 to pi by 2. So as I told already, 0 to pi by 2 means pi value 22 by 7. So 22 by 14 will come. So both also positive. So clearly we can take x power 99 is greater than 0. Multiplying 100 both sides. So 100 into x power 99 is greater than 0. We can take it as equation number 1. Here also cos x belongs to the first quadrant. So cos x is greater than 0 because for all the value of x belongs to the interval 0 to pi by 2. So cos x value we can take it as greater than 0, that is take equation number, inequality number 2. Adding inequality 1 and 2, we will get 100 x power 99 plus cos x is greater than 0 So therefore f dash of x is greater than 0. Finally, f of x is strictly increasing function on the interval 0 to pi by 2. So option A, it is strictly increasing. Option B is strictly increasing. Option C also strictly increasing. So what is our option D? Option D is correct. So our option D is correct. What is option D given here? None of these. So none of this. Option D is none of this. So that is only correct answer. Clear? Now question number 14. Find the least value of a such that the function f is given that f of x equals to x square plus ax plus 1 is strictly increasing on the closed interval 1 to 2. So this function f of x is strictly increasing means, so we will find the value of a here if the function is strictly increasing in the 1 to 2. So what is f dash of x now? F dash of x equal to 2x plus a. Clear? So this f dash I am going to take it as g of x. So this g of x equal to 2x plus a. Now what is the value of g dash of x? G dash of x equal to 2. G dash of x equal to 2 means we can say that g dash of x is greater than 0 for all the value of x. For all the value of x, g dash of x greater than 0. So g dash of x greater than 0 means clearly we can say g of x is an increasing function. G of x is an increasing function in the interval 1 to 2. So g dash of x, g of x is increasing function in the interval means we can clearly say that g of x is attaining maximum at 2 and minimum at 1. So g of x attaining minimum at 1 means clearly we can say that instead of this g of x we can use g of x value, we have taken f dash of x, so we can use f dash of x. So f dash of x, so what is g of x maximum value means g of 1 is the maximum. So g of 1 is, sorry, g of 2 is the maximum. So f dash of 2 is maximum value. F dash of 2 is maximum value. Similarly, f dash of 1 is minimum value. F dash of 2 is maximum value. F dash of 2 is minimum value. So f dash of 1 is minimum value means we can say that f dash of 1 is minimum value. F dash of 1 is minimum value in the interval 1 to 2. Therefore, so f dash of x is a minimum value means we can say that f dash of 1 must be greater than or equal to 0. So f dash of 1 greater than or equal to 0 means substitute there. So we will get 2 into 1 plus a must be greater than or equal to 0. Now a must be greater than or equal to minus 2. Therefore, the minimum value or the least value, therefore the least value of a is minus 2. Next question. So question number 15, what is given? Let I be any interval designed from minus 1 to 1. Prove that the function f of x equal to x plus 1 by x is strictly increasing in I. Is strictly increasing in I. This interval is disjoint from minus 1 to 1. So we should exclude that the minus 1 to 1. So what is the value of f dash of x? F dash of x equal to 1 minus 1 by x square. So 1 minus 1 by x square, taking LCM, we will get x square minus 1 divided by x square. So when it will become less than 0, if you are taking x values equal to, minus 1 or greater than minus 1 means that will become negative, numerator will become negative. Similarly, if you are taking x values Greater than, less than minus 1, less than plus 1 means it will become negative. Clear? So we should not take the values minus 1 to 1. If you have taken minus greater than minus 1 values you have taken means, for example, if you have taken greater than minus 1, 0 you have taken means it will become negative. If you have taken less than 1, 0.5 means this will become negative. So this will be negative on only in this interval values. So actually we have taken the interval I disjoint from the interval. So clearly we can say that this f dash of x is greater than 0 for all cases, for all the value of x belongs to I. What is the value of I? I equal to, I is the interval disjoint from minus 1 to 1. So it is not I minus, it is I is disjoint from minus 1 to 1 means we can take the values minus infinity to minus 1, then minus 1 to infinity. In the between the values, plus 1 to infinity, in between the values we are not considering. So in this interval it is greater than or equal to 0. This 1 to infinity also greater than or equal to 0. Actually it is hiding here. So what does that means? I must be minus infinity to minus 1 and plus 1 to infinity. So in this interval, in both intervals f dash of x always greater than 0. Therefore we can conclude that f of x is strictly increasing function. Question 16. What is given here? Prove that the function f of x equal to log of sin x. F of x equals to log of sin x is strictly increasing in the interval 0 to pi by 2 and it is strictly increasing in interval 0 to pi by 2, strictly decreasing in the interval pi by 2 to pi. I need to prove. So how to prove? We have to find the f dash of x. What is the f dash of x? Differentiation of log x equal to 1 by x. So 1 by sin x will come. Again into x in the place, what is that? Differentiate and we have to multiply. Differentiating sin x equal to cos x. So that is be equal to cos by sin equal to cot x. So cot x when we become 0, so that we can find, or we have given only two intervals, we can write that cot x is greater than 0 for all the value of x belongs to 0 to pi by 2. That is open interval 0 to pi by 2. It is first quadrant, cot is positive. So f dash of x is greater than 0. Therefore f of x is strictly increasing on the interval 0 to pi by 2. What about second case? Pi by 2 to pi, second quadrant, only sine and cosecant only positive. So clearly cot x is less than 0 for all the value of x belongs to the interval pi by 2 to pi. Therefore I can conclude that f dash of x is less than 0. Therefore f of x is strictly decreasing in the interval pi by 2 to pi. Clear? Next question, question number 17. Same question model. Prove that log of cos x. Previous question log of sin x. This question is log of cos x. So f of x equals to log of cos x. This function is strictly decreasing on 0 to pi by 2. Strictly decreasing on 0 to pi by 2 and strictly increasing on pi by 2 to pi. See that? Now what is the value of f dash of x here? As it is in the previous question, 1 by cos x. Differentiation of log x equal to 1 by cos x. Then differentiation of cos x equal to minus sin x. So what is the value of f dash of x? F dash of x equal to minus tan x. So f dash of x equal to minus tan x. Now clearly we know that tan x is greater than 0 for all the value of x belongs to 0 to pi by 2. Now multiply, we need minus tan x, so multiply by minus means inequality will reverse. So minus tan x will be less than 0. Therefore minus tan x value nothing but f dash of x. F dash of x is less than 0 for all the value of x belongs to the interval 0 to pi by 2. Therefore f of x is strictly decreasing on the interval 0 to pi by 2. Second case, what I need to prove? Strictly increasing on pi by 2 to pi, I need to prove. Now next case, so what is second case? Pi by 2 to pi. So clearly we know that tan x is negative in the second quadrant. That is x belongs to, for all x belongs to the second quadrant, pi by 2 to pi. Open interval pi by 2 to pi. Tan x is negative. So multiplying by minus, we will get greater than 0. The inequality will reverse, greater than 0, whose value is nothing but f dash of x greater than 0. F dash of x greater than 0 means, therefore f of x is strictly increasing on the interval pi by 2 to pi. Clear? Now come to the last question, question number 18. So question number 18, what is given? F of x equal to x cube minus 3x square plus 3x minus 100 is increasing in or we need to prove. So now what is the value of f dash of x? F dash of x equal to 3 times x square minus 6 times x plus 3. We have take 3 common. So remaining will be x square minus 2x plus 1. This will be equal to, with this we can write x minus 1 whole square, x minus 1 whole square. So clearly we know that x minus 1 whole square is greater than or equal to 0. Why I am adding equal to 0 means, for x equal to 1, this f dash of x equal to 0. That is f dash x equal to 1, this will become 0. So it will be always greater than or equal to 0. So we can multiply 3 before. So 3 times x minus 1 whole square is always greater than or equal to 0. So I am getting f dash of x is greater than or equal to 0. F dash of x greater than or equal to 0 means we can say that, therefore f of x is increasing function. F of x is increasing function. If it is strictly increasing, means it must be greater than 0. But it is greater than or equal to 0. That's why we have written increasing function. On which interval? On real numbers. On real numbers. All real numbers, this function is increasing function. Next to last question, 19th question, MCQ. What is given here? Find the intervals, the function is increasing. So f of x equal to given function x square into e power minus x. So what is f dash of x? We have to apply chain rule. So product rule. So differentiation of x square equal to 2 power x into e power minus x. Then x square into e power minus x into minus 1. So what is common here? E power minus x common. Remaining will be 2x minus x square. This again factorizing means I can write this as x into 2 minus x into e power minus x. X into 2 minus x into e power minus x. So our points intervals are, if f dash of x equal to 0, if f dash of x equal to 0, this implies x equal to 0 or x equal to 2. So our intervals will be split as minus infinity to 0 or 0 to 2 and finally 2 to infinity. We have to take any one point and substitute in the f dash of x. Actually what we need to find in this interval, each interval it is increasing function. Increasing means it must be greater than 0. So substituting one point from the interval, for example, if you are taking minus 1 and substituting means minus 1 equal to negative, and here substituting minus 1 that will become positive. So positive into negative will be negative. So negative means decreasing. So in this interval the function is decreasing function. Substituting 1 what will happen? 1 into 1 positive, e power minus 1 also positive. So it is increasing function in the interval 0 to 2. So next interval is what? 2 to infinity. 2 to infinity, substituting 3 means 3 is positive. Here substituting means it will become negative. So negative means decreasing. So only this interval f of x is increasing. So our option D is given, that open interval 0 to 2. So this is correct answer. Clear? Thank you. Next class we will see Next exercise 6.4 we will see, because 6.4 also deleted, 6.3 and 6.4 deleted. Next class we will see 6.5 maxima minima concept. Thank you all.